Chapter 9 Thermochemistry Exercise 9.89 During heterolactic fermentation, glucose is converted to lactic acid, ethanol, and carbon dioxide. Lactic acid has a formula of carbon 3, H6O3, ethanol C2H5OH, and finally carbon dioxide. The standard heat of formation of each chemical is given here. 1, 2, 3, 4 chemicals. Enter a balanced equation for heterolactic fermentation of glucose, and then part B, calculate the standard enthalpy of reaction. So first, part A, how do we write out the balanced chemical equation? We have 1 reactant, 3 products. So we'll just write out the reactants and the products on the 2 sides of the reaction, specify the phases, solid, gas, solid, and liquid here, and then balance the equation. First, glucose on the left, in the solid phase, arrow here from the reactants to the products. We have lactic acid over here. This is in the solid phase. We have 2 more chemicals. We have ethanol, which is just alcohol. Let's see if we can make it a little wider. This is in the liquid phase. And we have CO2 in the gas phase. Alright, we have all the chemicals and the corresponding phases. Now let's try to balance the equation. First, let's look at carbon. We have 6 carbon atoms on the left, 3, 2, 1, 6 carbon atoms on the right. 12 hydrogen atoms on the left. We have 6 here and also 6 here, 5 plus 1. So the number of hydrogen atoms is 12 on the left and also 12 on the right. 6 oxygen atoms on the left, 3 plus 1 plus 2. Well, that's also 6. So this chemical reaction is already balanced with coefficients 1, 1, 1, and 1. It's pretty simple. Now calculate this enthalpy of reaction. This circle means standard enthalpy of reaction, which means every single chemical is in the standard state. How do we tackle the problem? It's pretty simple. We'll have the enthalpy of formation of products minus the enthalpy of formation of reactants. We have 3 products, 3 different chemicals on the product side. The first one is lactic acid in the solid phase, which is negative 694, and this is ethanol or alcohol, negative 277.6. We also have CO2 on the product side, and now minus the reactant. I'll put everything for the reactant inside this pair of parentheses. There's only one reactant here, which is glucose in the solid phase. Alright, now the answer is negative 91.8. This reaction releases heat. So if you start from glucose And due to this heterolactic fermentation, you get lactic acid, ethanol, carbon dioxide, which is a alcoholic beverage, and then plus some heat, because heat is released with a negative enthalpy of reaction.